to solve systems of equations. So we solve by graphing. That means we graphed two lines and found where they intersected. We solved through substitution, where we put parentheses by a letter that was by itself, brought it into the other letter. Now we're going to solve through what's called elimination. So today you can solve a system of equation through elimination. Now, so there's three ways to solve a system. Graph it, substitute, or eliminate. Three different ways to do it. So, eliminate means get rid of. Like if I eliminate a problem, I'm getting rid of it. If I eliminate ants in my house, I'm trying to get rid of the ants. So it's get rid of one of the variables. Get rid one. What? Get rid one of whatever. Excuse my grammar there. You're getting rid of a variable. Of a variable. You're not going to get rid of two variables. You're going to get rid of one. Okay? How? Well, we want to cancel. Now let me show you how you cancel, because I think this is pretty intuitive once I guide it to you. So, if I wanted to cancel out -4, what would you add to it?
+4.
I would +4. If I wanted to cancel out 7, what would I add to it? I would add a -7. You see what I'm doing? If I wanted to cancel out 1, what would I add to it? Okay, you don't have to write all these examples down, but see what if I wanted to cancel out -13, what would I add to it? 13. So do you agree that when you add the opposite, it cancels it out?
Yes.
That's what today is. If we can get one variable to be an opposite of the other variable, one cancels out. I'm going to briefly go through the steps, but I don't want you to get too hung up on the steps right away. So again, eliminate, cancel. That's what today is. So to eliminate or cancel, we want one variable to be the opposite of the other. So bubble that. So if I had -13, I wanted +13. If I had +7, I wanted -7. Okay? So my goal is to be opposite. Then I'm going to add, box off add. Then I'm going to solve, and then I will get the other. Okay? So, make sure I can cancel them out, so make sure they're opposite. Add them, solve, get the other. Now watch this process. Do you see how 4 is opposite of -4? All right, so the x can cancel out to solve this system of equations. These are two lines. You could graph these two lines to solve it. That would be ugly. Could you use substitution? Is there anything that's all by itself right now? No. So I'm going to use elimination. Now watch how easy this is. How easy I make it look is really the technical. If I add them together, what's 4 plus -4? 0. So the x's canceled out. What's 2y plus y? 7 plus 2? 9. Okay. Where did the x go? It disappeared. Now, what's y then? Divide by 3. What's y? 3. Y is 3. Now I have to get my other. Now there's two equations you can use to get your other, and the other is the hard part. So pick one. You have one equation you could use or two. I usually use whatever doesn't have negatives. So I'm going to bring this to that y. I didn't have to, but I think it's easier because I don't have to deal with negatives. So then I have 4x plus 2 times 3 equals 7. X plus 6 equals 7. Four x equals 1. I can already tell substitution would have been ugly anyways. X is 1 over 4. So these two lines, remember a system is lines. These two lines intersect at the point 1, 4, and 3. So again, my process. I got one to be the opposite of the other. I added. I solved. So opposite. That's what I did. First I did opposite. And then I added. That's what I had left after I added. Whoops, then I solved. And then I found the other one by plugging it back into an equation. Okay, so let's do a couple more for today and then I'm going to call it good for eliminating. Again, the first thing that I need to do is make sure that they're opposites. Well, I do have opposites on the y, but a lot of kids get confused with the y's. Personally, me, who I do substitution all the time, or not substitution, elimination, I don't combine the y's. My goal is make my x's cancel out. I don't know why, it's just I'm used to it. Make sure the first things can cancel out. So, is 3 the opposite of -1? No, what do I want to turn this into? What's the opposite of 3? -3. So I want to put this, I want a 3 in front of that. So watch how I do that. I times all of this by 3. And this is that question that, do we ever have to make them the opposite? This is me making x the opposite of 3x. Distribute to everything or you will not get the right answer. Okay. Now watch what I do because this gets really ugly. So I rewrite my first equation so they're right on top of each other. It didn't take me long. Annoying, yes, but didn't take that long. Now distribute. 3 times -1 is what? -3x minus 3 times 2 is 6. 3 times -8 is -24. Be careful for signs. So that was first, opposite. Second, I'm going to add them now. Now that I made them opposite, I'm going to add. So I'm going to add these two equations. 3 plus -3 is what?
0.
Cancel. 2 plus -6 is -4. 12 plus -24 is -12. So now I added. So third I solve. Y equals 3. Okay. Now comes like the blah part, where I have to put it back into the first equation. So fourth, I don't know what's an easy way to say that? Put it back into an equation, bring to the top. I don't know, Tyler? Regroup is good. I'm trying to think as simple as we can, right? Plug it back in. Yeah, I think I'll plug in, plug back. Plug back. That's what I'm going to say. Plug back. Okay. That means that I bring this to any equation you want. You have this one or this one. I'm going to bring it to the top because there's no negatives. So this is going to go here with the y because that's a y. So 3x plus 2 times 3 equals 12. 3x plus 6 equals 12. Subtract 6, 3x equals 6. X is 2. Okay. One more. Tyler?
I got the exact same answer and I did it a different way.
Okay, one sec. All right, looking at this next example, I'm just glancing through to see if they're opposite coefficients. 4 is not the opposite of 2. 1 is not the opposite of that negative 3. So I have to change something. What do you want to change? What would be easy? The bottom? I like the bottom because the top is 4. So what can I turn 2 into to get rid of 4? What can I turn 2 into? What's a common denominator? 4. So I'm going to turn 2 into negative 4 by timesing through by negative 2. Okay, again, this is where it gets, you're going to have a lot of different equations hanging out. So what I'm going to do is just rewrite my top one and distribute. Anytime I distribute a negative, remember I said my strategy was to turn things to plus a negative. So I don't mess the signs up. If you mess the signs up, you're going to mess the whole problem. So negative 2 times 2 is negative 4x. Negative 2 times negative 3 is 6y. Negative 2 times negative 2 is 4. Now I can cancel. What cancels? 4. Yep, that canceled out. 1y plus 6y is how many y's? 24 plus 4 is what? 28. Y is 4. So that was the solving. Now I plug back. So now this, and you pick an equation. I'm going to go ahead and bring it to the top because there's no negatives. So 4x plus 4 is 24. Take 4 away. 4x is 20. X is 5. This algebra is not elementary, isn't that right? I mean, this is intense algebra. This is where the rubber meets the road. But I don't know what that saying is. But this is where everything from middle school gets pulled together right here. Do you know how to add integers? Do you know how to distribute? Do you know how to combine like terms? Do you know how to be careful for signs? Do you know how to solve? Do you know how to plug in? It all comes together.